Hey everyone, welcome to this video on using Yolov8 for object detection on custom datasets. YOLO is a deep learning model that can detect objects in real time, and right now it's really famous for computer vision applications. So to learn more about Yolov8, you can simply check out their official documentation. I'll provide the link on the description. You can simply check it out. So in this video, I'll show how to train Yolov8 on your own custom dataset and use it for object detection. So let's get into it. So the first step is to prepare your dataset. So you can collect and annotate your own datasets using various tools such as Label Image, CVAT, Roboflow, and etc. But remember, Yolov8 requires a specific type of annotations, and the annotation file should be in .txt format. So I will use Roboflow to annotate my images. The reason for using Roboflow is Roboflow provides a lot of useful features which is really beneficial to us. And you can create a workspace where others can help you to annotate your project. So it's really cool. So first of all, you have to go to the Roboflow website and then click create a new project. Then name your project for this and fill up those, like I'm detecting football players, and the project name should be football players detection, and keep the project type object detection, and you're good to go. So here you have to upload your dataset, and your dataset is basically the images. Like I have some images of a football field. I only have 3, and I'm showing this for just example because I already have a dataset like this. I already have a dataset in this zip folder, but I'm showing this for the examples, like how you can annotate your own images. So I'll upload that folder. It was in downloads, I guess. Yeah, click upload. Alright, it loaded my images, and click save and continue. It's uploading our files. And then click assign images, and we're ready to go. So start annotating, and here we can annotate our objects. So if I zoom in and then right click on, like you have to create a bounding box like this, and then label your annotations. Like this is a player, so I'll write player and then save and enter. Just like that, you can annotate anything. Let's try to annotate our goalkeeper. Save and enter, and you can see you have two classes right now. One is player and another one is goalkeeper. So we move on to the next image. This is a player, and this is a goalkeeper. It's really easy. Moving on to the next. Same process. Player. You can select from here. It's alright. We are done here. We successfully annotated our images. As you can see, we have 0 unannotated and 3 annotated pictures. So add 3 images to dataset, and Roboflow will split your dataset into 3 parts. And as you all know, to train a machine learning model, you need to split your dataset into 3 folders. So this is really a useful feature from Roboflow. And if you want to use another annotator, you have to do this thing manually. So we don't have to do anything with this. Click add images, and here it is. This is our dataset, which consists 3 images only. So yeah, and one for test. And Roboflow split our images into 3 folders. Like, it stored 2 images for training and 1 for test. I guess there wasn't enough images for the validations because we only have 3 images, so that's alright. And then you have to go back to your project. Here it is, and click on your project. And here are the steps we have completed. We have uploaded the source images, split the dataset into train, test, and split. As you can see, 2 images for training, 1 for testing, and unluckily we don't have enough images for the validation set. So the third step is pre-processing. Just click continue, and do the same for augmentation. Click continue and click on generate. So from here you can export your dataset into a zip folder. So click export and download the zip. Download zip to computer, and you have to change the format. And we are using Yolov8, so we will select YOLO and click continue. It will download a zip folder. So here it is. We go to the downloads. If I go to my downloads folder, here it is, the zip folder. If you extract the folder, alright, extract here. This is the folder. And you can see it has 2 folders called test and train, and we don't have a validation folder for because we didn't have enough images. So if you go to the test, you can see 2 folders named images. It has the image, and labels, it has the annotation. And in train it's the same, images, 2 images for training and their corresponding annotations. And if you notice, the annotations are in txt format. Properties, yeah, here it is, .txt. Alright, so after creating our dataset, let's train our model. So I'm training my model in Google Colab because Colab provides a free GPU, which is really helpful for machine learning model if you don't have a GPU. So let's move on to the code. So this shell, I'm connecting my Google Colab. Let's run it. And YOLO is a package created by Ultralytics, and we're also importing IPython to display our images. So this is it, and here we are just importing our YOLO model. And in this shell, we're testing Yolov8 with a pre-trained model called Yolov8n. N means nano. You can run it if you want to see how YOLO performs, and I'll skip it. I didn't run those shells, sorry. Showing requirement already satisfied because I already installed those packages. So we'll skip this. Let's load our dataset in the Colab. You can load a folder in Colab. Instead, you have to convert your folder into a zip folder. Then you can upload this. Like, I already have a zip folder, not this. I guess this is the folder we created with only 3 images, and this is where it is, and this is actually the main dataset. So let's open it. Okay, it will load our dataset. So yeah, it finally did load our dataset, and it's because my internet, my laptop, my life, they're always lagging behind. Okay, never mind, we're used to it. So let's move on to the next part. So after loading our dataset, let's unzip this zip folder. To unzip this, you have to copy the path and then paste it after writing unzip q paste and run this. So after unzipping, you can see we have 3 folders here, and if I go to test, you can see there are 2 folders called images and labels. In images we have our images, and in labels we have the labels of those images. And it's similar in train. We have a lot of images in train, I guess over 200. Yeah. And in labels we have the labels, and the same for the validation. And these folders, these aren't that important. You can delete those. Like I downloaded this dataset from Roboflow, so it has some instructions, so you don't need any instruction while I'm here. So let's delete those. Yeah, let's delete. What the heck is happening here? Delete everything. Okay, we don't need this zip anymore. And if you notice, we have an extra file called data.yaml. If we open this, you can see that it has some parameters, and these are provided from Roboflow. This part, we don't need this. So to train a model in YOLO, you have to provide the paths to the script by an YAML folder, just like this. So we have a train section, val and test section. So you have to provide the path of these folders here. So the train path, I'll simply copy the path like this, and then paste it here. And same for the train. Oh, sorry, is it okay? It's all right. So same process for the test and validation. Copy path, where's the valid? Yeah, alright, we're done here. The next part is NC. NC means number of classes, and in this dataset we have 4 classes here. One is ball, another one is goalkeeper, and there's player, and there's referee. And you have to change this according to your dataset. Like, you get this if you are detecting cats and dogs, you have to rename this to 2, write cat and dog here, and you get the idea, I guess. It's really simple. So you have to create your own dataset, data.yaml file. You can create it simply, like right click on your PC, then new, then text document, and then rename the .txt into YAML, then click enter. Okay, so it created an YAML file, and you can simply write down necessary information in this folder. So we are all set. We provided our paths, number of classes are 4, and these are the names. Next, we're defining model as YOLO, and you have to provide the YAML file path. I'll simply copy the path and then paste it. I guess the paths are same. Okay, you're training in 25 epochs. You can change this parameter, and epochs are basically how many times you wanna preview a whole data set to the model. In this, I provided 25, and the model will review my whole data set 25 times. If you don't get decent accuracy, you can increase or decrease it. So it's up to you. So we are set to train our model, and this is this training script. And our task is detect, mode is train, and we're using a pre-trained model called Yolov8. S means small, and pre-trained models actually helps us to create a decent custom model. And in data, you have to provide the dataset location. Now, you remember in data.yaml, we provided the locations of our paths. So you have to provide the data.yaml files location. So I'll just copy the path and then paste here. Yes, this is our data.yaml files path. Epochs are 25, image size is 800, plots are true. So don't mess with those numbers. Then let's try to run it. It will start training in a moment. So our training process started right here. You can see it completed 2 epochs till now. It will complete 25. Then it will give us a train file which we can use for object detection. So let's skip this part. So our training process is done. It saved our model in runs detect train. So now we have to validate our model. Before that, let's recap the whole process again. So first of all, we install ultralatex and we import YOLO, and this is a testing script. You can skip it if you want. Then we loaded our dataset, and our dataset was a zip file, so we unzipped here, and then assigned our model as YOLO, provided the YAML file link. Then this was our training script. It was trained in 25 epochs. And this is our model in runs, detect, train, and this is the confusion matrix. Here it is. And ball was less detected, and it totally makes sense. Ball is 0.6 and players are 0.94. Basically we have a lot of players and we just have one ball, so this makes sense. If it checks some validation images, you can see our model is doing really well. It's kind of detecting players perfectly, so our model is well trained. So you don't have to run the validation, but we'll do it anyway. So I ran into some problems while running this script, like this one. So I solved this using this. The error was something like UFT8 or some stuff. So if you run into some problems like UFT8 is not available or something like that, you can run this script. It will solve the problem. So let's run our validation part. We can check the results in detect.val. So in detect val, you can see the validation batches. Yeah, the model is performing really well. It can detect the goalkeeper, players. We check another image. Okay, done here. And our model was saved in runs detect train. So in train, in weights, and these are our models. It was the last model and this is the best model, so we'll use the best. So let's test our model in a video. To test your model, you have to write a script like this. Yellow task equals detect, mode equals predict, because we are predicting from our custom model. And here you have to provide the path to your best.pt. So I'm just gonna copy our path and then paste it. Okay, this is our path, and the confidence should be 25. Let's load a video. I have a video on my machine. So this is the video. I'm gonna copy the path and then provide the path in source. But if you run into some problems like this, you have to rename your source video. Let's rename our file because it has some slashes and stuff. I guess this is the problem. Okay, let's rename our file. Rename like 1.mp4. Okay, so let's provide the path. The name was really too long. I have the predicted video in runs detect predict. I already downloaded the video. If I show you the video, this is it. The accuracy is really decent. It's detecting the ball also. This is the goalkeeper, I guess, and it's kind of confused if this is the goalkeeper or not, because I didn't provide any images from this match on my dataset, and the train a model with like some more data, you can have a better performance. So after training, you can simply download your weights like this. This is the model actually, and then use it in your project and stuff and do whatever you want. So that's it from today. See you on the next video. Bye bye.